Hi, I'm Alejandro Ramos from the University of Santiago de Compostela. It is a pleasure for me to present this webinar in which we will explore how fuzzy sets can help improve natural language generation systems. We live in a world flooded by data, where huge quantities of data are being created at this very moment. Did you know that by 2020 there will be 50 billion of connected devices? This means every person will have 6 devices, all of them online at the same time. Another interesting fact is that 100,000 tweets, 680,000 posts in Facebook, and near 48 hours of video on YouTube are published every minute. In fact, 2.5 trillion of bytes are generated every day. In order to be useful, relevant information must be extracted from this data. However, this task is difficult even for experts, given the enormous sizes of datasets. And although we have several different techniques to facilitate this task, such as data mining approaches, statistics, or visualization tools, these are inappropriate for non-expert users. As a result, there is a wide gap between data and human users. One approach which helps shorten this gap is natural language generation, also known as NLG, which addresses the problem of creating texts automatically from information contained in other kind of sources. In fact, we can distinguish different kinds of NLG such as interactive systems, narrative, or data-to-text when raw numeric data is the main source of data. As a research field, it has been in development for more than 30 years. It also has a very strong commercial side, especially in its data-to-text specialty, where several companies offer NLG solutions for several different application domains. Let's have a look at some real examples of texts generated by NLG systems. Here, we can see two different texts generated by the BabyTalk family of systems. These have been created from the same input data, but for different end-user profiles. In fact, it is accurate to say that the domains in which NLG systems can be applied effectively are quite diverse. Here is another interesting example about data from Google Analytics. Weather forecasting agencies, such as the British Met Office, also make use of this kind of solutions. However, despite all its greatness and maturity, NLG as of today has paid little attention to the vagueness inherent to terms in human language. In fact, we aren't aware of any real NLG system that currently handles this problem. This is where fuzzy logic comes into action, since fuzzy sets allow to mathematically model imprecise linguistic concepts in human language. Within fuzzy logic, a very interesting derived discipline is the creation of linguistic descriptions or summaries of data, which addresses the creation of summaries of data handling imprecision. These summaries are based on the concept of a fuzzy quantified sentence. In short, a numeric dataset can be described based on a fuzzy linguistic partition of its numeric domain and a quantifier partition. A fuzzy quantification model, such as SADES, allows us to compute quantified sentences that describe the original data, with their associated truth degrees. Sentences like "a few days in January were warm" are easily obtainable with this kind of approaches. Additional computations can be performed on linguistic elements to obtain more complex statements, such as "between several" and "many days in January were cold." So far, we have seen linguistic descriptions of data are focused on the summarization of data into imprecise linguistic terms and structured statements, while natural language generation covers the whole process of producing texts from data. So how can they relate to each other? Linguistic descriptions of data elements can address several natural language generation tasks, adding imprecision handling capabilities to this kind of systems. Let's have a quick look at some of them. The first task of a natural language generation system is content determination. This is, to determine which content is going to be included in the generated text. That means that we have to extract from the input data the relevant part of it that we want to reflect textually. Linguistic descriptions of data and fuzzy sets perform this task in a linguistic way. Consequently, if we take a look at the lexicalization task, which in fact consists in choosing which words will be used in the output text, using linguistic descriptions of data, we are already done with it, since we already know which linguistic terms have been chosen, for instance, based on the truth degree of the quantified statements. Referring expression generation is directly related to lexicalization, but from an increased level of abstraction. In short, it is focused on choosing which features allow to distinguish a certain entity from others of the same kind in the text. Taking into account that these features would probably be imprecise, this could also be performed through fuzzy techniques. Finally, we reach the aggregation task, which consists in reducing the number of messages into more complex but less repetitive sentences. It is feasible to aggregate several quantified sentences based on their truth degree or additional criteria. So, as you can see, the exploration to a full extent of the potential relationship between natural language generation and linguistic descriptions of data is an extensive challenge. We have made a first step in this regard with the creation of a textual weather forecast generator named GaliWeather. This solution, which produces texts in Spanish and Galician languages, is currently in service for Meteo Galicia, the Galician weather agency in northwestern Spain, whose website receives 55 million visits per year. Fuzzy sets were used to perform content determination tasks related to cloud coverage, for which there wasn't a clear specification by the meteorologist. This ambiguity allows us to create descriptions using imprecise terms and fuzzy quantification techniques. For instance, our first approach was to perform a chronological description of the cloud coverage by dividing the whole forecast period into 3 subperiods, which are defined by fuzzy labels. Each label measures how well each value in the input dataset fits into its corresponding subperiod, for example, beginning, half, or end. However, in some cases the weather is too variable to be described chronologically. That's where quantified sentences come into action. Instead of providing a chronological description, in this case we are performing a global description which quantifies how often a type of cloud coverage appears in the input data. For this, we obtain quantified sentences such as "the skies will be occasionally clear." As you can see, linguistic descriptions of data techniques were useful to solve specific problems in the creation of this natural language generation solution. However, instead of telling you myself, let's see what a real meteorologist thinks about GaliWeather and its benefits.
So GaliWeather gives us an added value because we can now make a forecast for all locations in Galicia using all the information that a human can use. The system is now deployed here in Meteo Galicia and we can produce more than 300 site-specific weather reports in less than a minute. We don't lose any quality because the system is made with our advice in the language, in the structures. It's a tool very well adapted to the needs we have here in the service, so we are very glad with the system and we plan to continue this collaboration because we are happy with this solution.
For us, GaliWeather is just a first step in this endeavor we are undertaking, but at the same time, it is a proof of the interest of exploring in more depth how fuzzy sets and linguistic descriptions of data can advance in the same direction with natural language generation systems. Now that we are finishing this webinar, to sum up, the main highlights of this topic are the following. Terms in human language are imprecise or vague, but natural language generation pays little attention to this. So, in this context, we believe that to explore the relationship between fuzzy logic and natural language generation will benefit both fields from both a research point of view and an application perspective. By modeling and taking into account the vagueness in natural language terms, we can improve the human likeness of the texts generated by NLG systems and adapt better to how human beings produce texts. This has a very high impact potential, as natural language generation is becoming increasingly popular, motivated by the explosion of big data and the appearance of the robot journalism, which essentially means creating news-oriented content in an automatic way through the use of NLG systems. I hope that you have enjoyed this webinar and that the topic we have explored today has awakened your interest. Thank you very much and see you soon.